Welcome to the SolidCAM University channel. This video's topic is handling large files. So by large files, I mean a file that is large relative to the internal features or relative to the tool you're looking to use. So a good example would be a mold that may be oversized, let's say a foot or more, but internal to the mold, you have little faceted surfaces, little small surfaces that you would see with an injection mold or that sort of thing. So large files such as those, they tend to have two things you need to consider: the calculation of 3D-based toolpaths and the simulation of the overall toolpaths. So we'll tackle those one at a time. So basically, the way SolidCAM could help with the calculations and that sort of thing is inside of each 3D toolpath, there are things like working areas or boundary conditions, boundary constraints. Those have been covered in previous 3D eye machining, 3D milling, and the HSM, HSR toolpath videos on the YouTube channel. But internal to each one of those, you would use a working area. So I'll show you examples of those when we actually open up a part. But majority of the thing that's going to help you with the handling of large files is actually setting the parameters to handle large files. So let's begin with those. So on the global settings side, if we were to go to Tools, SolidCAM settings. So we'll open up our SolidCAM here. And one of the first things you want to do is turn off the loading of the target. So loading of the target is actually something you'll do when you get to the global settings, toolpath simulation, and it's right here. So target loading. So that's actually the model you've defined as your target, rather than loading it inside of your simulations for things like the stock analysis or anything like that. If you don't intend to actually do a stock analysis, or you don't want to do it right away and you want to just get to the simulation part, you can turn this to don't load, meaning that it'll actually not load the target model in the simulation, and you can go right into doing simulations of the actual toolpath on the stock definition. If you want to load the tool, load the target model inside the simulation for the stock analysis, there is an option to do that there. So you don't actually have to load it right up front. The next thing is the autosave interval. So there's actually an autosave inside SolidCAM, and you can see that here in the miscellaneous, and I have it set to a very large amount. Now by default, this is around 10 minutes usually, but right now I have it set to basically 6 hours. All this does is it doesn't tell SolidCAM to do any autosaves as you're calculating a toolpath or as you're trying to simulate the toolpath. That could bog down the calculation, that could bog down the simulation time. So I've set it to 6 hours. It's not going to engage the autosave. So that might be something that would be of a concern of yours, but some of the things that I'll be showing you today would help with that. But the autosave is not on, but that's just autosaving. You can still save your file as you go along. Okay, so that's on the global side. So let's actually open up a large part example. So I'll just go to my recent CAM parts. Example of large part. Now, a fully programmed large part, it does seem like it does take a bit of time to load, but again, that is just the largest part. Again, kind of a definition of large part. Keep in mind that everything inside of this window is faceted. So you're going to have facet tolerances for the stock, the target, fixtures, your tools, everything. So that's what actually makes it large. If you're using the same sort of facet or you're faceting everything, imagine something this large faceted with something that is maybe only a few thou of an inch large. So that's another thing to keep in mind when you're looking at these files. You can change your facet tolerances and such, and we're going to go through that right now. So if I go to the settings of this part, so again, just a review of settings, the global settings are what you set outside the part for any file you create, and then when you do open up a part, such as this part right here, these settings are actually copies of those global settings. So if you do large parts a lot, and it's kind of your main function in your machine shop, then you can set all the settings I'm about to show you here in the global settings file. But let's go through the settings for using large parts. So there's a function during the solid verify where it actually updates the stock model and saves a copy of that. And you can control that under part settings, updated stock calculation, solid verify. And right here, you'll see stock model update method. By default, this is usually set to maybe 1. So after every operation, it updates the stock and saves that stock so that when you leave the simulation window and come back, you already have a stock that you can simulate a toolpath on top of. Now, with many toolpaths, many large toolpaths, that is going to be a little bit cumbersome, because if you had to load that target, that updated stock every time, that could slow down the simulation time. It's actually faster to not save it and then recalculate it from scratch every time. That'll actually save you a lot of simulation time, and it'll actually clean up some toolpaths. So if you've got a large, let's say 3D machining toolpath, and that type of toolpath depends on what came before it, it will actually be faster to not save the previously machined stock and just calculate it every time. So in respect to that, I've set the setting to 0. So it won't actually save my updated stock with every operation. It'll just build upon whatever I've simulated at the time. And it'll recalculate it every time I turn on one of these toolpaths. Okay, next is the method itself that we're going to use for simulations. There's actually a function called special for HSR and HSM. So that is separate from the regular default setting. This is special for using the 3D toolpaths. So that should streamline some of the simulations as well. Okay, and if we return to that previous window, you'll see that my tool facet tolerance has also been changed. Normally, the facet tolerance for the representation of the end mills, the ball noses, the tools in general, that setting is, I believe, around maybe 2 thou or something like that, or should be closer to what your normal settings would be for your facet tolerance of your stock and your target. Here, I've put it at 10 thou. The representation of the tool is not exactly necessary for some of these large parts. It's still going to generate a toolpath that's correct, and the dimensions of the tool are still correct. So all the math that's going on behind the scenes is still correct. It's just that this facet tolerance is for just the representation of the tool. So it's not a big deal to make this 10 thou, especially when we're considering that we're trying to save time with simulations and calculations. Now, if you do this, I have noticed with some versions of SolidCAM, the facet tolerance makes the tool look a little strange, but that's only because it's being represented with a very coarse mesh. So if that ever happens, it might just be something you can check here to see if your facet tolerance is a little off. Okay, and then, okay, so next is the type of simulation we will actually use. But before I go to the simulation, let me just jump back to the calculation parameters we could do. So I mentioned earlier in the video that with a part that's rather large like this, it might take a long time to calculate it. Say, for instance, this side here. So I've got a couple of slots here. I've got 5 slots here. In reality, I probably could just do one 3D machining and then just let the tool go and find what it needs to find to calculate the toolpath. But knowing that this is a rather large part and I don't want to wait forever for the calculations for the whole thing as a whole, it would be better for terms of saving the model, because remember, we don't have the autosave right now, and just the overall calculation, I could calculate them separately. So using working areas, that's what I've actually done. So if you look at my 5 slot toolpaths over here. So I have 3D machining for slot 1, slot 2, slot 3, and so forth. And I've added a working area that essentially is for slot 1, slot 2, and so forth. So each one of those is a 3D machining. It's going to take the stock and the target, compare them, see which material needs to be removed, but it's going to do it within that working area. So to see how working areas work, I'll refer you to the 3D machining video on the YouTube channel. But essentially, that would be my recommendation for working with large parts. Use the working areas to actually section out certain bits that would make sense to section out. Say, for instance, this rather large feature over here. This would take a long time to calculate with 3D machining, but I've separated it in the first level, so that calculated pretty quickly. And then it saved me time and calculation time, simulation time, and that's worth when I set up 3D machining for the lower half. Pretty much focusing on this area here, but I left it behind to do maybe a little bit of cleanup, and then so forth. So using the working areas, you can actually section off certain areas that don't necessarily have to be machined all at the same time. So you can actually simplify some of the calculation. Now, in terms of simulation, all those parameters I put into place, let's take a look at them rather quickly. So let's just see if we go and do this toolpath. So if I went to Solid Verify, it would try and load the faceted stock model. It would have the faceted tool and all that. Solid Verify is not what I would recommend here. Solid Verify is the most commonly used simulation, but it's not actually good for large parts. Because of the way it works, it's actually a very accurate simulation of the toolpath. And because of that, there's a lot of calculations that go on. It actually uses Boolean algebra, Boolean logic to represent the tool. So as the shape of the tool engages your stock, it actually removes that shape of the tool from that stock, and it's constantly being done as it's moving along the part. But so many calculations on a large part, it could really slow down your computer. It could really bog down the simulation. So that's why we have Quick Solid Verify. If I click on that, it brings up a less complex version of the stock. So right now it's actually just updating itself to represent the updated stock. Quick Solid Verify is actually the more recommended option, because the way it works is it doesn't show each movement of the tool. It doesn't do the Boolean algebra, the Boolean logic with each pass. What it does is it represents the result of the tool path after so many steps. And there's actually a section, if I can get to it, Settings, General, right here. So the animation interval, this is usually set to, I believe, 10. I've set it to 1,000, which is the maximum value, meaning that every 1,000 lines of code will be simulated. So you can imagine for a 3D machining, that is actually going to be very beneficial, because I don't need to see every tricoidal movement. I just need to see the result of the toolpath. Again, this is not fully accurate right now, but I can still use my stock analysis. I can still use all the analyses that are available to me in the regular Solid Verify here. I'm just using Quick Solid Verify to get a quick representation of the toolpath. So I'll press play on that, and we can see my tool doing the work. That is every 1,000th line of code. So there's a lot of lines of code, so it actually does look like it's doing a bit with each pass. But if I were to Solid Verify this, we would see every single scallop. So, and if you're familiar with Solid Verify, you'll see what I'm talking about. Now, one of the things that is actually a little different with the Quick Solid Verify is because of the way it simplifies the representation. We're looking at it right now, and it is somewhat of a high quality representation. But as soon as this wheel stops turning, if I angle it, we'll actually see that it becomes a coarse representation. And that is another one of the settings inside of Quick Solid Verify. With each rotation, movement, it actually switches it to a very simplistic representation. And then once I do that, I can actually click high quality and then bring it back to that high quality representation. So if I just angle this a little bit, okay, so you can see that it does not look very good at this moment. It's kind of very coarse. All I got to do is click on high quality, and it brings it back to that high quality rendering. So if I wanted to zoom in and take a look at what I've done in certain corners and whatnot, all I have to do is rotate it and then click on high quality once again to bring it back. Now, with Quick Solid Verify, now that I've run it as is, I've brought up the Turbo Mode button. So Turbo Mode is, it skips that 1,000 line of code representation, and it goes right just to the end of the toolpath. So by clicking turbo mode, it's just going to show me the result of the toolpath itself. And we'll see that once this stops thinking. In this case, though, because we've represented the one toolpath, it's probably just going to blink and then show us the final toolpath once again. So it's the calculation of these massive toolpaths with these large files, and it's the simulation of the toolpaths of these large files that we're addressing in this video. In terms of the posting G-code, that is something that you can discuss with the SolidCAM post team. There are certain things that they can help you with there as well. Any other questions on SolidCAM in general, any other questions on toolpaths, even how to modify these specific toolpaths, because keep in mind, a lot of the times it's geometry specific, what you can do to streamline some of your operations. You can always give us a call at 1-866-975-1115, extension 2, or you can submit a ticket using the technical support ticket system on solidcamsupport.com, or stay tuned for the rest of the videos on the YouTube channel. Thanks for watching.